Hello. I hope that now the connection will be a little bit stable. Really hope that this is not going to be again dropping out. In the Ventspils Business Center, internet connection, as you know, is really bad. So today I had discussion with the ISP service. They found out, I think, the problem back in their ISP service. So we'll see. Now I'm trying to do this from the hotspot, and yeah, hopefully this will gonna hold. So yeah, confirm that you can hear me. Just like type in plus if you can hear me. If you can hear me, plus, minus. If the connection is like at least reasonable. So we are 8 people now on. I would like to see some pluses from the students who are doing the work together with me. So nice to see David's, Kirill, Christopher's. I did not see the homework finished from David's. I did not see a lot of homeworks finished from Kirill, but it's good that you're here at least. So what about the other guys and girls? Is there? Can you hear me? Please post the plus sign if you're ready. So I think. Really great work from Christopher's. He submitted homeworks. I saw also from Lee, our Chinese student, who is not today. He gave already a message for me that he is not today. So I will just maybe show you. Bye. So yeah. So like it's especially students who are working with me. Please do their homeworks. Otherwise, we will not get your thesis work. It will be really hard to finish thesis if you don't do the homeworks. Okay, that's cool. I like also that Christopher is engaging with YouTube chat and posting the questions. I saw that Everett's at least one of the homeworks finished. Please do others. Alessa too. So I'm still waiting from pluses. So I have 1, 2, 3, 4, 5, but we have 9 listeners. So what about others? Are you ready to work? So we'll do the homework explanation a little bit. Of course, not probably all of the parts, but some of them. So if you go in the classroom and download the template that you had for the homework. So I really hope that when I will start doing stuff on internet, it will not drop me out. But I will try not to do a lot of. So in the classwork, there's a homework and then there's a template. So not sure why there are 2 templates. Using calculate accuracy, using the template to do. Using the regression task, change it to the classification task, right? So yeah, let's start by the second task, and then I will also add the accuracy part. Okay, that's great. So we need to merge basically 2 tasks. So please take those templates from the classroom, both of them basically. The main part will be based on the 7th session regression PyTorch, and then we'll change the dataset. I think, yeah, change the dataset basically. Yeah, I think that should be it. So let me move back to the code. So Arena also good. Haven't seen some of the people who are watching to sign in with the plus sign, so I'm not sure about you. Yeah, please let me know if you're ready to work. So okay, so this is the template that we had from the homework, and from the last time. Okay, what we have here? Just a second. Yeah, so this is the template. And from the last time, what we did together was I think it was wine dataset, right? To the 2 kinds of wines, right? So let's find. I will find quickly the place where the dataset is located. Okay, here, load wine, right? actually very little changes needed in this template. So when you put on this PyTorch California regression task template, then all you need only to change basically here the data sets. Okay, not giving me the autocomplete load vine. Load vine, right. Import navi load vine, right. So I will try to run it at least. So it will not work, but still. So just to make sure that it's loading at all. Okay, seems okay. Load vine. So yeah. So please get yourself ready to this moment where you have the template from the homework with the PyTorch at the end, and change the datasets to the load vine, and we will change around a little bit the code to make it work for this particular problem. So just to reiterate where you need to go. So you go inside the inside the Google Classroom. Go with the 8.3 homework, and then take the template session 7 regression PyTorch, and here you will need to change the California dataset to the load vine. So when you're ready to this moment where we can start working together, then post a plus sign. So we'll move back. Ready to work with template. So I'm posting in the question. I know the internet might be choppy, and I might be, like the voice might not come through always. So let me know if you lose some of the parts that I'm telling you, and I will try to repeat them. So. Okay, so we have 1, 2, 3. So maybe I can stop my back connection. Let's see, maybe it will work. So we have 1, 2, 3, 4, 5, 6 pluses, but we are 9 people here. So I'm still wondering what are those 3 or 2 people that are still connected and not giving any response for me. So anyways, the other guys that are in the course can watch this later, but let's start working with this. So let's see. And maybe I can change this to the very low resolution to make it a little bit better. Okay, cool. So we need to load the vine. If you look at previous time that we did the work with the NumPy, with the cross entropy and Softmax, then you remember that we had to convert this to the one hot encoded probability distribution with the size of 3 classes. So this is basically the same thing that maybe we should do today. So we have the dataset for loading the vine. That's good. So, and here we can remove this line of expanding dimensions, because at this case it doesn't make sense, because this is y is containing the class indexes and not actually the features. Okay, my internet is choppy, sorry for that. So y is containing class indexes, not the features. That's why we remove that line there. Okay, so just to remind you, let's check what we have here. Just to remind you. So we have we have 13 inputs and 3 outputs. So the shape of the x is so x shape is samples, comma 13, and shape of the y here is just comma samples, and these contain index class indexes in range 0 to 2, basically len 3, basically len classes is 3. So this is what we have there, okay? This is what we have there. So the model, we need to change the model basically. So we want to change first that we have 13 inputs and 3 outputs, right? So this is what we know. 13 inputs and 3 outputs. 13 inputs, 3 outputs. Okay, that is what we need. So the other part of the architecture can stay the same, or you can change it as you wish. Not that important. So then let's change also the SGD to some more fancy like learning algorithm, optimizer algorithm. So let's say Adam, or maybe it will be fun, RMS prop. This is the optimizer that I think, if I remember correctly, Karpathy, the guy that I referenced quite a few times, Tesla AI director, and one of the first Stanford AI course lecturers for deep learning. So I think he invented this function, this algorithm, and then posted in some kind of blog post, and now everybody is using that for classification. It's a kind of reasonable way to do this. So, and also learning rate, let's change it to E-4. So the changes that I did now, I will put them, not losing them. So first, regarding the set, let me remind you one thing. So if you are Windows users, then please install, and you don't have 2 monitors, then please install the, so let me switch to this, on-top replica. So let me show you this tool. So Google, okay, loading, on-top replica. So this app will help you to make a small screen that you can put on top of your coding window, and it will show you like the contents of what we are doing right now. So I'm not sure if you already installed that, but this is something that you need to install in order to have better experience of these workshops if you are on the Windows. So basically it looks like this. You select the window and then it makes a replica. Usually people use that to watch videos while working or stuff like that, but you can use that to clone some window and then put it on top of your coding screen. So that is a good tool, and for Mac users it's in picture. There's a GitHub also link. So let me remind you those tools. So I will add those here. So Windows on top replica, Mac, picture in picture, and for Linux, I think last time or somebody asked me, I'm not sure, there should be tool. If you know what tool to use, then please post to me as well. Be good to save it down. This is the first part of the change of the code. Then the second part was with the model, and so it's not actually finished, sorry. So the second part, let's finish the second part. So there is missing Softmax. Remember that we need to have Softmax at the end. Torch, and then Softmax. So okay, let's stop here. Ask one question now. So dimension. So first, over which dimension should we calculate Softmax? So Softmax dimension, over which dimension? Which dimension should we use? So to answer this question, you need to think about what are the shape and size of the input data, what will come in this model. Like you definitely know at this point what is always coming in the first dimension, right? Then think what will be in the second dimension. And then think, is there any third dimension actually or not? So, and then please answer the question. So I'm still waiting for that. If you don't know the answer, then type in minus, so maybe then I can explain a little bit and understand better what you understand. Remember also the way how the how you start counting dimensions. You start counting from 0, right? So Christopher is saying dimension 3, right? So he is thinking dim 3. What about others? So minus if you don't get it, don't understand. Okay. Okay. It's better that you post minus than don't do anything. Then at least I understand where we are. Otherwise, I will still keep getting it harder and harder and harder, and then you will be completely lost. So better engage with the chat. So, okay, 0. David thinks that's 0. Okay, so those guys who at least answered something, maybe you can like type in why do you think your answer is correct. The best way how to argument me the answer is to write with the, some like reasonable words what you have in the size of the input. Okay, so good. I have at least decent amount of the answers. So none of the answers are correct. So the correct answer should be dim1, but this is good that we understood what you don't understand. So when the x comes in here, x size, or let's say x shape, I think you can call also like that. So the x shape here, this is super important to understand. The x shape here contains batch of the samples, right? So I'm just right now explaining, Christopher. So it contains batch of the samples and features. Basically, that is the shape that is coming in here. And so if you look at the shape, then if we choose the dimension, okay, I will try to repeat things. If there are some problems, then type in. Explain it a little bit better. I will have another question. But before that, let's examine a little bit about this B and F. So in this particular sample that we have here, let's look around. So if you have the same code file that I have, so yeah, there is a problem with internet, but at least I hope that it comes alive time to time, and it will not be that bad that you cannot follow at all. Sorry for that. So maybe I don't know what I could do actually. I'm just hoping that it will be more stable. Keeps freezing. Miss 2 minutes. Cannot be 2 minutes. That bad. I understand that it's freezing sometimes time, but not 2 minutes. So okay, just to repeat this part. So the batch coming in, the size coming in of the x is batch by features. If you look at dimension 0, that is batch. If you look at dimension 1, that is features. What is batch? Features. It's always like most likely like short-handed by B and F or something like in that realm. So my next question then is what is the scalar values of this shape? So what is the integer values of oh seriously, my internet is dropping really bad. So if it will be that terrible that you cannot even follow what I'm doing here, then I will probably interrupt the session and go to connect to the LAN cable and try it again. So just let me know if it gets that bad that you cannot follow. Then I will make another YouTube link and we'll get with the hopefully a little bit better connection. It seems like now it's really bad. Let me think, what can I do to improve it somehow? Anyway, so let me know if the connection gets really bad. The scalar values of B and F. So this is my question. So for example, I want answer 77,88, for example. But it should be the correct answer regarding this particular sample. Okay, Christopher's telling 16 by 3. What others think? Please type in also your option or answers. To understand these parts is quite important. Otherwise, these are really easy parts. But if you skip them, then it will become harder and harder and harder. And when I answer these questions, and if they don't match to what you thought it will be, then please think about it very carefully, make breakpoints, and maybe ask more questions or write me an email or whatever, so you'll completely understand what's happening. If you don't understand this question or the answer of this question, then please type in minus so we can move on. So I'm still waiting for some of the answers, or minus, or something. So, okay, I see Alice's answer, I see Christopher's, David's answer. Please, others, if you don't understand or don't know the answer, then please type in minus, or should I move on? Okay? If the internet connection is that bad that you cannot follow, also please type in so I know. So more answers, please. Okay, Kirill, very nice answer, I like it. That is, so Kirill spoiled it a little bit, that is correct. So Kirill answered that it will be 16 by 13, by 3. I mean, so it's not correct answer actually, but he type in the way that maybe it is understandable better. So the first is the batch size, that is correct in Kirill's answer. The second is not correct because that is the output of the x, but not the input of the x of the this function. So the input here. So let me type in a little bit. By the way, I reduced a little bit video streaming quality, so let me know if it's too bad. Yeah, Everett's what wrote that is correct way. Yeah, so 16 by 13, because this is what we have in dataset. We have 16 samples, right? 16 samples is the batch size. We are splitting our dataset here by 16 samples. We're going 16, the next 16, the next 16, and each of those samples contains 13 features, like the alcohol level, like the, let's say, pigments and stuff like that of of every sample of the wine. And then when we have here, let's say y prim, this is our predicted value shape. This is what we get out of the multiplications by matrices and dot products, where we can change the shapes, is by 3. These are the 3 classes of the output. I really appreciate the engagement that you type in some of the things. Why in features and not out features? So think about it a little bit. This is our whole model, right? All of the functions together. So far the video was some 30 seconds behind the chat. Had to increase the playback speed to catch up. Okay. Yeah, not sure what I can do about it. Let me know if somehow the chat is still like lagging behind really badly. Hopefully it will not lag that much later, because I capped my output streaming to the 2 megabits. Hopefully it will be okay. If it will not be okay, maybe I will reduce it a little bit more. So let me double check about the settings, what I can do. So the output, I think it should be quite okay now. Anyway, so the input is the one that we get from the dataset, like here, by slicing the dataset. So if we slice the dataset, we get exact dimensions in the last dimensions as we have in the dataset, right? So I don't know actually, Christopher's, how to explain it a little bit better. If you can give me better, like formulate again the question, then I can help you to understand about the in and out features. But in basic terms, remember that we have vector that we multiply by matrix of different dimensions, and with the dot product operation we can change the size of dimensions using the dot product operation. Hopefully that helps. So the next question is then, so if we look here, the last function that we have, this is a softmax function, right? So my question is, what are the properties of the softmax function? Why we need it? What are the properties of softmax function? Why we need it at the end? So we remember last time we talked about this a lot. We looked at a lot of equations. If necessary, we can look at those equations again. Meanwhile, while you're typing the answers, I will add those screenshots a little bit to the Jamboard so others can follow a little bit better. So I'm still waiting for the answer on this question. You could look at the equation, you can remember what we talked about, you can answer yourself. It normalizes results, if I remember. It also makes the big values bigger, small. So good answers. But what like the second part of the question, the answer of the Christopher is really great. The first one not so. So what is like the mathematically the main properties that that softmax will do to the vector? So if I give some vector with random values, what will I get out? Please type in maybe others as well. If you don't know the answer, type in minus. It will help me to explain you better. If you don't engage, you will get lost even more behind. So I really hope my goal is to equip you to finish all of these research works that you're doing, but you need to engage with these sessions, okay? So I'm still waiting for those answers, okay? Okay, good direction, Kirill, regarding the probabilities. But what does it actually mean in the terms of scalar values? So, well, I will give you a hint. What will happen if you sum all of the values of the vector together before the softmax function and after the softmax function? Like, can you give some more answers regarding this question, please? Thank you also for the minus. It's like any engagement to provide better content regarding to understanding all of these mathematical questions. So I'm still waiting for more answers. Please, if you don't know the answers, then just type in minus so we can move on and learn something together. Before it will be random, after it will be equal, it should be equal. So Kirill and Christopher's, I think, got it like in like a ballpark, you know. So let me quickly find you the softmax function, but I'm really not so happy that the others didn't engage, at least or at least like Alice gave minus. That helps me to better explain things, but please others engage a little bit better. So let's see. Maybe you're behind the chat. That is also possible, actually. If you are behind the chat, like because of the internet delays, then I guess the best way is to skip to the to the point where we are, and then time to time check if you're not behind because of the delays in internet. Sorry for that. We'll try to resolve next time. So here is the equation, actually. So the output layer could give you all sorts of random values, right? And like it's not actually random, but they are called logits. They are the values that make up the this vector that represents your class distribution. And then the softmax function, when you put it through the function that for like every element here, 1.3, 5.1, and so on, puts that in as an exponent here, and then sums the exponents below. You can see exactly what Christopher's told, that the small values get smaller and big values get much bigger, with reference that the maximum value is 1 and minimum value is 0, and the sum of all values is also 1 as a proper probability distribution, because if there would not be sum of 1, then that would not be proper probability distribution. So the reasoning why we need this is because the cross entropy loss functions that you use for training the probability distributions come from information theory, where everything depends of digital data transmission with zeros and ones, and like the entropy functions work with one hot encoded distributions where there is only zeros and ones, and softmax pushes large values towards 1 and small values towards 0. So that is the reasoning, and this is the function, and so hopefully it helps you to understand this better. If it's not understandable still, if it's not clear still, if there are some questions, then please type in them, ask them. Because as I said, since we move on, it will get like more difficult and difficult. So okay, moving back to the code. So remember that last time we spent a lot of time explaining that this is much more important to, this is super important to predict the probability distributions and not the class indexes, because we have the class indexes like class 0, class 1, class 2, but we want to predict the probability distribution for each of those indexes, because the distances between the scalar values of the indexes and probability distributions are very different. I mean, like the probability distribution distances are about the same between each class. So it doesn't matter which class is first, which class is second, which class is third. But during the training process, when you start training process, you can choose that the first one will be the red wine, white wine, some kind of, I don't know, like black wine. So, and then you can swap them out, you know, make another data set where the red wine is second and the black wine is first and stuff like that. So if you swap them around, it will not make difference in regards to like training process. But if you predict the actual class indexes, it will make a big difference. So we cannot do this with the regression. We need to do the probability distributions. I don't know if it makes sense. So anyway, so here we have batch size. Here we have this part. So remember that now the ty is not properly set up. Ty is containing the indexes. So let's do another test now. So let's keep on digging on this. So ty, what will be the size here? Size or shape, doesn't matter, shape. What's going to be the ty shape here? So the hacky guys can run debugger and answer me the questions, but I hope it would be cooler if you can answer directly just by looking at it. So at this point you should be able to look at the code and answer these questions because they are quite important. At least if you don't know, then just, I don't know, you can guess, you can type in minus, that's also fine. So all of these things we already discussed quite extensively last time. I was hoping this time we can move to the convolutional neural networks, but if we have some serious problems with these questions, then we need to talk about them more. So this course that I'm running here, this workshop, is much more relaxed than some kind of university workshops. University workshop, you will just move on and then you're left behind. Now we can repeat some things many times if necessary. So look carefully, please. This is ty. So one thing that I changed probably from your code is I removed the expand dimensions line. So make sure that you don't have that line there. And then basically the answer, if you don't have that line there, is following. It should be 16. So like scalar values of the indexes of the classes. So my next question, again, just to double check that you understand what's happening here. What kind of values can be here? Like what numbers or what values? So this is my next question. Inside y, ty, right now, what kind of values can be there? If you don't know the answer, just type in minus, then I can explain it. Otherwise, I'm just still sitting and waiting. Okay, Kirillov gives 0, 1, 2. What about others? So funny that we left 6 people. We started 9 people, and then so I guess those who did not engage dropped. So yeah, so I have 3 answers. What about others? Okay. Yeah. Okay. Well. Yeah. So the okay. Good. Good. Thank you for engaging. That then at least I can try to explain. So all of the data that we have here, they are vectors. So just to keep you explaining, so these X is a matrix of all of the samples. S means samples, so there are, let's say, 10,000 samples. Each of the samples are different types of wine samples. Each of the samples have 13 features, like the alcohol level, the color, pigments, and stuff like that. And the Y is for every of those samples the class index. And class indexes, as the guys correctly listed, they can be from 0 to 2 because there are 3 classes available, and you start counting from 0, of course. And then if we select out here the segmentation, so this is a Python syntax to concat, I mean not concat, but slice from IDX to IDX, from IDX to IDX plus batch size. If we slice out that part, we get the slice of the classes, and if it be X, the slice of the features. And here we have the slice of those features that can be so 0 to 2, basically, let's say 0, 1, 1, 2, those are the 3 classes. But in order for them to be usable with a cross entropy, that is our loss function, now here we have mean absolute error, it could be mean squared error or whatever, but for the probability distributions we cannot really use that. It's kind of incorrect mathematically. So the correct way to use this is to use the cross entropy here. So that's going to be also a small task. But now let's convert the 0, 1, and 2 indexes to probability distributions, because we don't want indexes, we want probability distributions. We want vector that shows what is the probability for each class to happen, right? To be the correct class. So to do that, we can, let's say, try to rewrite it. So let's write ty. This is going to be our just ty tensor y, and this let's rewrite this tensor y idx, because these are actually the indexes, idxs. Ty will be, we will create a template, small template to hold all of those values. So this is going to be the zeros, the template of zeros. The first dimension going to be our batch size. The second dimension be our class size, the 3, right? Then we will fill those parts with the indexes. So minus 2 minutes again. That's interesting. So where can I help you? How can I help you? It seems like if others like not only Everts but also others feel that you like dropping behind a couple of minutes like all the time, then please type in chat so I know that this is a like a serious problem, that all the time it's lagging behind. At least my network connection seems to show that we're a little bit stable upload of 2 megabits. Let's see. So let me know if that is some problem that occurs regularly. So now I will try to not move that fast. It's actually good to go slower with these things. So ty. Then what we're gonna do is set the values at every index. Set the values at every index. Thank you, Christopher, for letting know that it's okay with you. For every index, depending. Set it as 100% depending on the index. So here we want to do the torch arrange by the size of t, but basically by the size of the batch size. Okay, keep skipping. Okay, I don't know, what can I do then? hopefully it will not be necessary for the rest of the session. If you see that like it's again lagging behind all the time, one option is to maybe reduce a little bit the resolution. Maybe the problem is also on your side of the network, not only on my side, so that you can reduce the resolution, because everybody is now in the evening at home in the internet. Maybe they are clogging up internet also other places. So yeah, in the videos you can, yeah, okay, you can increase the that's interesting solution, increase the playback speed. The other option is maybe reduce a little bit the bit rate, or like you can choose it at least in that manner that it's still readable text. So maybe I will zoom it a little bit. Anyway, so we select indexes in a range of batch size, and here we select indexes by the TYX. So if we have the just a vector or list of indexes in Python and in PyTorch and in NumPy, we can select two-dimensional arrays by giving the list of indexes, and we actually don't need to give every element, like do the for loops, for example. So, and here you give them 100% accuracy for each of those indexes. What I also gonna do maybe is I will do as a comment here explaining the lines above, explaining lines above, 2 lines above. So you don't code this stuff, but I will just show you. So basically, the lines above is exactly the following thing. So we go over in range batch size. So we can write in one line what we can write with the 2 for loop, basically, I guess, with the 2 for loops. So, for example, we can then select, we can go over the batch size, then basically we can go over the so the y. So you don't need to write this, it's just to explain what actually those lines above mean. So we go over every element then, and then let's say ty, where there's I and j. So, and if let's say then ty index, where there is I, matches the j here, then we will give this as a 100% accurate, else this is 0% probability. So these lines that I wrote here, and I will comment now, these are just to explain the lines above. So 2 lines above explained by following lines, follow lines. So my question is it clear how to convert indexes to the probability distributions using the PyTorch? Is it clear how to convert class IDX to prob distributions? So that's my question. So type in plus or minus. If maybe it's a minus, then type in some question, exactly what is not clear regarding this. I have 1 plus. So 1 plus like phone, right? So I will put this code also in the Jamboard. So I have 2 pluses. I have 5 viewers. 1 guy is dropping out. That's sad. Okay, so we'll have, yeah. So we'll have pluses. Everybody is understanding. That's great. So the next thing is the cross entropy. So let me show you that. So LaTeX or LaTeX tool. Maybe I can even share the screen while I'm typing this, because otherwise maybe you will get bored of this. So the loss CCE is the following. So this is a sum of, there's going to be minus in front, of 1 frac 1 divided over n samples, and this is going to be the y multiplied by the c dot by the logarithm of y prim, or basically we can just type it like that. And if I look at the equation, so that's a very simple equation. Basically this is correct one, categorical cross entropy CCE, or just cross entropy called some. So my next challenge for you is to please implement this line of code here, and please just copy this line inside the chat, so we'll see if you can manage to do that yourself, because now you have ty here and ty prim, and it's a very easy task now to do basically. So I will make this as something that I add in the Jamboard. So let me know when you're ready. So copy in here PyTorch implementation of categorical cross entropy loss. So wait for the answers regarding this. So basically you need to change it here. So to do change this line. So I will wait for the answers regarding this question. If it's not clear, please ask. Otherwise it will get harder and harder. So if I type in here the equation, let's see who can do this first and correctly. Basically, it should actually, if you implement that function, it could actually work immediately. So you could probably start running the code, and it would give you the loss function that decreases over time. And if you don't understand this and cannot do this yourself, then type in minus or either one of those things. It's like the minus is also like a reasonable answer, so that I know that what you know and what you don't know, and I can maybe even give some materials that you can learn to yourself. I'm hoping that my internet is holding up. The n in the equation is the notation how normally people write the calculation of the mean value by the number of the samples. In this case, it's actually the B, the batch size. But so let's see. So the Kernel gave one answer. So maybe that's correct. Let's wait for a couple of other answers. So please type in the answer or the minus sign so I know when to move on. Okay, so we have Christopher's answering. That's interesting answer. So let's wait about others. At least type in minus, then we can move on, you know, like otherwise we'll just losing the time, you know. The more time we lose, the less time we have to learn something new, you know, like just sitting around on the same things all the time otherwise. Okay, I have engagement from Christopher's and Kirill. What about others? Okay, cool. That's about interesting equation. At least, so it's better that you submit something than just not do anything. Minus sign is also good. Like otherwise, like I just will be keep moving. As I say, it will get difficult and difficult. So I have 3 answers now. I'm still waiting for some other answer. Like, I mean, if your goal is to submit like research work with using the like artificial intelligence and deep learning, you should be able to at least attempt or try to break those functions, you know. If, for example, what we do is so difficult that you even cannot follow these steps, then you need to contact me and I can give you maybe some easier stuff to start working with, but this will require serious work from your side. It's not, like it's not possible to do research work if you not put in the serious effort. So please, I'm still waiting for some other answer, at least minus, please. Okay, so we'll start preparing the next stuff that we're gonna do. Okay, Davids, thank you. What about others? So what do we have? Like we have 1, 2, 3, 4. We have 6 viewers, but we have 4 answers. That's a bit strange, but maybe. Let's see. Okay, so anyways, so I don't know what's happening with other people. So okay, we have another answer. That's excellent. Okay, so I see at least now some of the things that are problems, some that are good. So it's great that at least you know how to write those equations. The problems then become how to like exact precise way how to write them. So the loss now, let's see. So let's write the one way how to do this. So if we would like to write it in the So maybe I wrote it myself a little bit wrong, but yeah, so my mistake is basically we can write it as I wrote it. I think let me think if it will be the so yeah, so normally the one divided by n should go in front, I guess, but it should probably, so let me think, should probably work also in the inside, but it's kind of funny way. So minus, so let's say let's start writing it in a, like 1 divided by the batch size. So then this should be then, let's say, multiplied by the torch sum. So at least I think you know how to do the sum, so that's great. So and then the y ty basically, because that is the tensor value, right? So torch logarithm of the ty prim. So that's going to be the proper way of writing it directly like I wrote it, but let's examine it a little bit more. So I will maybe update the equation on the Jamboard in a sense that the 1 divided by n should go in front. I kind of did not notice, and nobody told me that I put in some like function that is because this should give the same output, but like nobody does it like that. So just a second, it's repeating the division operation unnecessarily. So just a second. Okay, so this is one way. This is one way. The other way, like how usually you would write is these like 1 divided by batch size multiplied by sum. This is exactly the same as the torch mean, basically. So this is exactly the same function. So that means that you can simplify it even. So just put it minus 1 in front and this part here. And maybe the other thing that, so it's actually not that bad. So here the multiplication sign, basically if we always look at the values by not looking at the batch size, because batch size is something just that comes naturally as this first dimension that you always don't count in, then this is just like a Hammond multiplication pairways by the dimensions. Sometimes, like in the equations, actually normally you would not add this c dot to make it clearer. But in this case, hopefully, at least from the equations that you gave me, you understood this idea, so that this is not a dot product, actually. So if we leave the function like this then, and if we try to run it, let's see what happens with our loss, right? So let's run it and see. So what happens with the loss? So, okay, we have problems. So the tensors must be long indexes, sorry. So the problem that I have here is that the indexes, of course, are not float, so we need to change them. Long tensor. So sorry for that. I did not notice that the indexes that, of course, are 0, 1, 2 cannot be floats, right? So you cannot select elements by floats, right? So if we change that part, then the loss works great. So let me, so I will scroll it a little bit down so you can see also that part. And meanwhile, I will update the Jamboard with this long tensor that we missed out before. And please type in when it's working for you. So loss working for you. So type in plus if it's working, minus if it's not working, question if you don't understand. So I'm updating the Jamboard with the new information regarding the loss function. That is cool. So we are slowly making our AI smarter, right? So now we got to the point where we can predict the classes before we can predict the prices, right? Next we need to predict the fashion. We will make a model that predicts what, like, is the image the like shirt, skirt, or blouse, or whatever. So that's going to be fun. So some problems. So if there are some problems, giving none n in output. One option is n in output. Maybe that is related to the learning rate. Learning rate could be 1 e minus 4 and RMS prop here, the optimizer. Maybe that could be a problem. I see a lot of pluses, some problems. If you have like very specific problems, you can maybe try to share in some manner the error code or the source code, like drop it in like a paste bin or some service like that, and type it in the chat so we can in the live session show others and help to resolve your problem. That is one option. Okay, the learning rate helped, right? That's cool, that's cool. So in general, all of you got this. So the last thing that we need to do before moving to the convolutional networks is that if we have like a model that predicts what kind of wine it is, it would be nice to know how accurate it is, you know. The loss function gives you actually the information, let's say, loss that is based on the cross entropy, that is not based on something that normal human being can understand. The human beings can understand the accuracy. So to calculate the accuracy, let's do the accuracy calculation. So we need first to add here in the top some kind of whole information holder, some array where we're going to hold the information. So accuracy is here. So this is going to be the accuracies. You can write it as you wish, but basically there should be some list on top of there. So this list, and then here below, when we are having the predicted value, so they have y prime here. That is actually the, right now this is a numpy value, but maybe we don't want actually. So, oh no, we have y also there. So that's cool. So we have two y's. So accuracy here. And now we're going to write some maybe small equation that might not be immediately understandable, but we will get to understand. So why? So we need to, let's say, convert IDXs, y prime IDXs, convert the probabilities back to the class indexes, because if the class indexes match, that means that we have 100% accurate prediction. If the class indexes don't match, we don't have predicted a correct answer. So here in top, also let's change this to the y IDXs. I also removed this part of the code so it's a little bit shorter, so I can put it all in the one screen, right? So I changed that this now is called y IDXs because they are actually just an indexes, not the probability distributions. They become probability distributions only after these two lines. So we know the correct class here, and we want to create get the predicted classes. To get the predicted classes, we can use the argmax. So let's say, let's write it in the first like this, torch argmax from this, and then dimension. So the mathematical function argmax, hopefully you know that. That means that you will select the index from the vector with the largest value. So if, for example, let me show you what argmax means. So if you have, let's say, 2, 5, 1, and you give to this vector argmax, it will give you back the value of 1. So is this clear? So if it's not clear, then I'm just making sure that it is clear. is it clear? If it's not clear, then type in minus or some question. And if it's clear, if you type in plus, then my next question is what dimension should be added here in this place? I know, but probably you know the max function, right? So the maximum value of the vector. But regarding the argmax, so let me know. So those who are posting the pluses, then please give me what is dimension here. What dimension should we give there? But if you don't get it, plus type in minus, so I know, because otherwise we'll just keep moving. It will get harder. Let me know, please. Nice, we're starting to get answers. That is very cool. But let's keep getting more answers. So as you notice that when somebody posts answer, I immediately not say if it's correct or not or correct. So don't take it as like if I say something that it's not correct. So we don't like first answer and then I will tell you if it's correct, because it helps me to understand what you know and what you don't know. Otherwise, we'll just like moving in some direction and we don't know if it's you already got it or not. So we have 4 answers in general. Like I see that we are a little like we are 6 people working on. Hopefully somebody else can also give me an answer. If not, we'll move on, and it will be more advanced AI, and you will need to understand more. So I appreciate if you post an even minus, because then I can explain. So the correct answer is 1, and this is because these are features, and the Kirill and the David's got it right. So if we would go it over the 0, then it would be really it would be really strange, actually, the output. I think it would be trying to get it over the columns some way. So it's not I even don't know what it would happen. So but basically here like to explain a little bit to Alisa maybe. So the max function that you have, so torch max or numpy max or whatever, so that would give you out the value of 5, right? Why do we need for max features? Okay, so we need, so the features are actually our probability distribution in this case. So it doesn't matter it's called features, because like at the end we have shape of 3 here. So our shape is here the batch size, comma 3, or the 3 classes. And we don't want to calculate the maximum value over the batch dimension. We want to calculate maximum value over the 3 class dimension, because maybe let me try to explain it a little bit. So, and I will also explain it about the max function, because it seems like that's a little bit tricky for some people. So let's say we have first output. So the first output will be, let's say, the 0, 1, 0. So this guy is predicting that this sample is the let's say red wine. So then this predicts that this is let's say white wine. I know somebody can help me out. What kind of third type of wine there exists, because I don't drink wine. So somebody then there's be predicting this wine. Then it will be predicting so let's say this one will be predicting that this is a 50-50 of this thing. So now if we calculate the argmax or max over the second dimension, that means that we would go by every row and calculate the argmax over or max over every row. So that would happen in that case. If we calculate the the Rosewine, thank you. I don't know, can you make Rosewine directly or by mixing too? So torch argmax dim over 0. Let's say that's going to be rose wine. I was inventing some kind of black wine. So anyway, are there black wine? So if we go over dimension 0, what would happen is that it would start collecting something like this over columns 0, 0, 0. This is not what you want, right? Or the next argmax would be over dimension 0 would be 1, 0, 0.5. Again, completely rubbish, right? But what you want is to have argmax over the dimension 1, and then you would have the samples in the sequential order by 0, 1, 0. The next sample will be 1, 0, 0. At this case, they are already like in the normal like distribution, right? But yeah, so they always will be in this distribution actually. So anyways, when we are giving this kind of question, what we get out of this is the IDX1. This is our answer with argmax. Here the answer is IDX0, right? And here, where we started at the beginning, but I started to explain the black wine is a thing funny. So explain the Alyssa regarding this max. So here, of course, if we have this vector and we want to find the maximum value, that is 5, right? And we can do the next thing, where is 5 located? And this operation is called argmax, and it will give you the index where it's located, and it's located in index 1, right? So now my question is, argmax clear or not? Is argmax clear? So, and why you need to select specifically dimension 1? Plus, minus, give me some answer, otherwise we will still keep talking about this. So Alice is a plus. I guess the previous guys were also plus because most of them answered correctly. So, okay, so we have dimension over this thing. So now we have a list of indexes of the predicted values, and we have a list of indexes of real values, right? So if we have two lists of numpys, so actually, sorry, here we cannot use the torch, but np, because this is already numpy, see numpy, right? So this is a numpy. The color of the wine depends on how much time does it spend with the grape skin. The longer, oh, that is interesting. I need to maybe write it down somewhere, because then I can pretend that I'm drinking a wine. So anyway, so here we'll have the let's say the correct case is correct. So, and if you have two vectors, so these are basically vectors, and this vector size is the batch size. If you have two numpy vectors, what we can do very easily is to compare them, right? So if you have y idx's, and if we compare it to this guy, what we will get out is the same size vector that will contain the values like this. So it will be true. This is this. So the dimension 0 match, dimension 1 doesn't match, dimension 3 doesn't match, dimension 4, oh sorry, false, the dimension 4 let's say match, and so on, right? So hopefully you can get this thing. So if we have this kind of vector, right, the other cool thing what we can do is we can convert the bools to the floats. So let's say then this is going to be the correct as a float numbers, floating point numbers. And if these are floating point numbers, what we can do is multiply it by 1, for example. And now we will get the values of, let's say, 1, 0, 0, 1, and so on. And then the last thing that we want to do is to calculate the average value of this, and we will get the accuracy of the batch, right? So there's going to be NP mean, because these are remember the NumPy vectors, right? So there are two types of the at least two or even three types of matrices and vectors. So one is the very simple NumPy lists like this, or maybe this is not actually the actual list, but this is the NumPy. So this is a Python list, right? There is nothing about this. So this is actually NumPy array, and this is the torch tensor. So when we operate with these things, we always need to make sure that they are in the specific data type. We cannot just mix together all sorts of data types. So here there are the NumPy list, right? And if we calculate this, we get the mean accuracy of the batch. And if we add the accuracy here as append accuracy, now we get the list of accuracies here, right? So, and then at the end, we need to calculate the average accuracy over the whole epoch. So, is the accuracy calculation clear? Is the accuracy calc clear? So, let me know. If not clear, we'll try to explain. Otherwise, yeah, we'll move on, and then you will lose your chance to get the explanation. So, okay, this is going to be the accuracy thing. So let me add the accuracies. So I called the session for ConvNets, but we did not yet reach the ConvNets. Doesn't. Okay, maybe at the end of this session we'll start exploring the ConvNets at least. So I'm still waiting for some more answers. Why do we need correct and correctf? We basically, Christopher, of course, we can write all of this stuff in one line. Basically, just putting it in 3 lines to explain it a little bit better. Because, basically, we could even calculate the mean over directly floats. Maybe it would work if the specific library supports that. Maybe the specific library don't support that. We never know, basically. So that's what we have there, basically. Okay. So if I'm still seeing only 2 confirmations that the accuracy calculation is clear, need more confirmations. So the guys who have finished this part, you can add here in the bottom part, of course, the accuracy is the NP mean of that list, mean of accuracies. The funny thing here that I just said, that this list is a Python list and this is a NumPy function. But NumPy is very friendly with the Python lists. It is not the case in the other way around, and it's also not the case with the PyTorch, you know. So NumPy and Python is a little bit more friendly than the other guys. So okay, if you run this, then we finally get to the next tasks, hopefully. So if I run it, it'll be really disappointing if, okay, it's not working. Why it's not working? So I'm using, oh, sorry, not dim, but axis. So I will need to update. Again, the functions look very similar between the PyTorch and the NumPy, but the argument names sometimes are different. In this case, again, the name of the axis I slipped out a little bit. So let me update that stuff. And we'll update that in the Jamboard. And if I run it, hopefully you see very nicely that the model starts to recognize white, red, and rose wine, or it does not. So in my case it was NaN. Let me see again. So now the next time it worked a little bit better. Sometimes the initialization might not work out. So there could be also some other reasons. Let me check. So the losses optimizer, step backward, that's fine. That is fine. Losses mean. Okay, we have a little problem here. The NaN could happen also because the logarithm here, the ty prim for specific axis can reach 0, and then logarithm of 0 is NaN. So here we need to add some kind of small epsilon minus e minus 8. So that is actually reasonable thing to do here. Otherwise it will be not numerically stable. So there is actually also other way how to bypass it. Be quite fun to see if some of you can bypass this problem by some other way. So if you look at the default implementations of this stuff in PyTorch and TensorFlow, they bypass in different way. So let me see again. So now the accuracies are raising. So see, the accuracies are getting better and the loss is getting smaller. So that is cool. So let me think a bit more about this. What we can do is increase the let's say the epochs, and probably it will converge to some good values. So if you add 100 epochs, so after 100 epochs we already get 55% accuracy. So I'm not sure what is the actual the best accuracy. The one way what we also can do is to make the model much more complex. So now we have a very dumb model, but if we add, let's say 200, okay, that's going to be a little slow training, but 32 dimensions, 32 dimensions, 32 dimensions, let's say 32. So this is like expanding the data manifold, and now we get 81%. See how just adding the more parameters to the model gave us better accuracy in the same amount of time of the the training epochs. Let's keep trying. So let's add 64. What will happen then? I'm not sure. There are some things that are missing here to get this to the state of the art, but this should be still quite reasonable. So if you run it again. Okay, now actually we get lower accuracy because now we get too complex. So this is the way how you normally train these things. You try to start with a very complex model, overfit it, remove complexity until it gets some decent accuracy. So okay, so this is working. If it's not working for you, you can adjust it a little bit. So the next thing is going to be regarding the convolutions. So with the convolutions, we'll not have too much of the time, but still will be interesting to discuss them and start working with them. And I will then prepare some homework for you. So I will add the first task to the Jamboard. So meanwhile, you can make your stuff working. Just a second. So this is going to be the assignment 9.2, simple ConvNet in PyTorch using a template. So I will add there a template for you. So that's going to be good news that you don't need to code everything from scratch. And the template will include the dataset loading, and I will explain about the dataset as well a little bit. So that's going to be there. And we also need to have one equation. So quickly try to find it for you. So okay, I will start by adding this task so you can access it. So 9.2 task, it's now accessible. So I will show it to you that you need to download the template. It will not work immediately, but it will work when we will change it a little bit. So go and get 9.2 template in front of you, and also you can look at this image and maybe copy that one as well for you. So, and I will add the formula on the Jamboard as well. So we are now in the 4th slide, the 5th slide, and so let me know then when you're ready. Just a second, Kirill is asking a question. So the test dataset is not yet implemented there, that is correct. The test dataset will be also in this classification task of images, and in the future tasks we always will use the test dataset. So please, so is 9.2 template ready? So is it ready for you to work on? Is it in front of you? So when it's in the front of you, then type in plus. If there's some problems, type in minus or problems, and I will meanwhile get quickly the equation for you on the Jamboard, and then we'll move on to the next things. So where was my equation? The equation, where are you? I could of course write it down, but this would take me a time, and I don't want to do this now. I just want to quickly get the equation. So I found it. Found the equation. Meanwhile, get ready this. So I have one plus there. So I will show the equation of the convolutions, and then also explain the convolutions and explain a little bit dataset, and then it's going to be really cool because our machine learning AI will be able to see the images. So that is something always quite cool stuff. So just a second, trying to copy the what? Oh, sorry, what is Tdqm? Yeah, I thought I removed it. Oh man, I remove it? TD, where is it? TD, okay, it's is it in the, yeah, it's in the import line, so remove it. So sorry for that, remove that Tdqm stuff. So that is just a console slider. So that is so I will show you actually where to remove it. So that is a console slider, I mean like progress bar or whatever. It is useful if you want to let's say show the progress of the coding, you know, like, so the training, I mean, but you don't have to take it. So I will copy it here, and please remove these lines that are basically gray. So, oh man, so remove the Tdqm, remove this one. Sorry for not removing them before. I was kind of not seeing them. And when you're ready, then type in plus, and we'll quickly move on with the convolutions, at least the introduction of them today. So, and if you want to try out Tdqm, that is quite cool library. You could actually pip install the Tdqm. You know how to do this. This is quite simple, right? Or use conda install. And this is actually quite useful library for the console development, you know. So we have the equation on the 5th slide in the Jamboard. So the equation explains the change of the size of images between convolutions, and I will explain it in a second. And I see that some of the guys, or some of the people are already ready for working with this, so that's cool. Trying still to get out some of the stuff. Just a second. Oh man, the new Evernote just really is not as good as the previous one, unfortunately. So just a second. I have my notes in the Evernote, and then it's just not working anymore as it's supposed to do. Just a second. So I need to open files just to copy them on the whiteboard. So I copied on the Jamboard also some pictures, and we'll try to explain it also with some slides. Just a second. Looking for, I'm lost my links. Okay, I see the pluses. Not able to install Torch Vision. Okay, that is interesting stuff. So the Torch Vision is something that you normally install when you have the PyTorch, because if you go, so let me show this stuff around. So first, if you go inside maybe I should share the full screen then. So if you go here in not tools, but here in the bottom part in terminal, then and then if you go back to the PyTorch, you actually will see the installation procedure for the Torch Vision. So if I choose your specific, like let's say the configuration, what you have here, Conda, Mac or Windows or Linux, whatever. So it gives you this line. So if you copy this line and go back inside here and copy it here, you see that it provides you install PyTorch, Torch Vision, Torch Audio from channel PyTorch. So if you install this stuff there, it must contain Torch Vision as well. So if you have problems with Torch Vision, you should try to reinstall the PyTorch using this line from Conda environment terminal. So with the Python, it's really not recommended to use all sorts of the Anaconda package UI managers and stuff like that. You will get problems. It's much better to use the console. So do that, please. And I will explain a couple of things now. So just a second, let me find where I have the Jamboard. So, and then I will show about the convolutions. So the convolutions are learnable parameters of the model that are the kernel function. And the kernel function basically is a function that you repeat many times over the same data input. So if you use the kernel functions, it means basically that you have some kind of like a small like a linear kind of it's actually not really linear, but it's like you use the dot product and then multiply and then sum together all of the scalar values. Basically it can be any function. You can invent your own kernel functions and then move over the whole image many times, and that would produce the output. But the convolutions actually do this in a very specific manner, and I think there is a great image like this one. So this image is basically very good explaining. So I will drop in the YouTube chat the link so you can open yourself this link and explore it later. So the way how this works is that you have RGB image, 3-color image, right? It can be also 1-color image. I mean that in this data set that we're going to work together, this is just like a grayscale image, right? Then it's just a 1 channel. And what you have here is a learnable filter or kernel that is like weight 1 and weight 0. And what you see here is that output of this stuff is two matrices, right? So like with the channel 0 and channel 1. So the input is 0, 1, 2. So you have 3-channel input like RGB, like colors, like, right? And the output is much smaller, right? First you see that this is much smaller output, and you have only 2 colors now here. Let's say colors. They actually called the channels. And how to do this is by repeating the operations of these filters as many channels you want as in output. So maybe I need to like draw some stuff around. So here, so how many, like the number of the filters. So this is actually like one filter with 3 dimensions here. See, one filter. This is just a matrix, 3-dimensional matrix, very small matrix, 3 by 3 matrix with 3 dimensions, right? So how many of these guys you have? This is that many outputs you will have. And basically the operations are really, really simple. So you take one of this guy, right? So basically it doesn't matter that they have 3 dimensions. You can just look at the first one. So you take one of this kernel, right? It's displayed here, right? And you move it by some stride. Let's say the stride is just two elements, right? So you move it here, you move it here, you move it here, and so on, right? So actually here. And every time when you move this, you multiply every element. So you multiply, let's say, this element by this element. So let's take another color. So you multiply, let's say, this element by this element. Then you multiply this, let's say this element by this element, and so on. And then when you have all of these elements multiplied by each other, you then sum them together with just a plus operation mathematically. When you sum all of this stuff together, then you place that output value, if it's in this corner, in here. So you place it here. And basically you do this for every pixel, you move this around. And you do this for every channel. So this operation is really, really simple. And you have also bias here that you add at the end to basically you add this to the any pixel that you have here. Oh no, I did not show you that. Sorry. So what did I show you? Just a second. Okay, thank you for letting me know that you don't see it. Sorry, yes, so I will repeat it, and next time it will be better because you already heard it once without seeing. So anyway, so again, the input image, right? So let's say these are 3 colors, R, G, B colors, red, green, blue, right? So, and then we have 2 filters, like filter 1 and filter 2, right? And the output image don't contain anymore the 3 colors, right? We have only 2 colors now, or it's also called channels. So the colors are also called channels. Now we have 1 and 2. And the kernel operations are the operations that you repeat many times by a specific pattern. The pattern is by skipping some of the columns or rows by using the stride. So we have here this kernel applied, for example, this one. It doesn't matter like which order, so just look at the let's say the first channel, right? So you apply those, then you move let's say by two rows here, you again do the same operation, you again do the same operation, you again do the same operation. So the one nice thing is that they are not dependent on each other, so that means that you can parallelize it. That's why GPUs are really fast with convolutional neural networks. And the other thing is that the operation itself is really dumb and simple. So you multiply, let's say, this guy together, you multiply this one together, you multiply this one together, you multiply this one together, and so on. You multiply all those together. Then you sum then the outputs that you have here, you sum all of the outputs together in one scalar value, just in one scalar value. And that one scalar value you put inside the output here. And the last thing is you add bias, plus bias. The bias is learnable, just one small stuff here. You see, there is a bias. So, and then basically you repeat this with the first kernel, you repeat this with the second kernel. If you would like here to have 4 outputs, for example, I want also here 3, 4, 5, whatever, that just means that I need more of these guys. I need 1 here, 2 here, again the same line of 3 elements for the third one, again same line of 4 elements for the fourth one, and repeat them just how many times, so basically repeat them, so have them for every channel we should have every filter. And visually it looks like this. So I think it was possible to enable this stuff. Okay, yeah, like that. So it shows you which of the calculations it's like doing right now, and how it looks like by the kernel. So see, right now we're going to the first matrix, and we are activating only the first kernel, right? Now we're going to the second matrix. We're activating only the second kernel, right? So is it clear or not? So, and if not clear, then maybe what exactly is not clear, so I can help you. So is it clear how convolutions work? So, and these red kernels are actually, you can think of them as the linear layer weights, and here the bias. Those are the values that you learn. Those are not fixed. Those you learn while you are doing the stuff. Yeah, the random. In the very beginning, the filter values are random, and when you learn them, they change. And they change in the direction to make the task of loss function easier, basically, or basically the gradient where it goes to the zero. So I think there was also another picture here. So I added also this picture. Maybe that is better. I'm not sure. So there's like the target pixel, right? You have the kernel, and then you multiply all of this stuff together, and then you sum it together, and then you get the output value there. And you repeat this stuff many times by moving, like, let's say, by step here, 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 here. So my question still holds, like, is it clear? If it's clear, then type in plus. If it's not clear, type in minus. And if I can help you explain it somehow, then also please let me know. So the thing is that this is called kernel function, and the kernel means the just like the small operation that you repeat many times over the input, and the input in this case most likely are the images, right? So we are interested in images, and it doesn't matter how many dimensions you have. You can have grayscale image, you can have depth image with 4 channels, you can have RGB image, you can have some kind of very custom stuff. So, and now we get to this point of the equation. So when you're doing these kernel operations, you want to make sure that your output is in the size that you can predict, right? You don't want outputs that you don't know what will be the size. Remember, in machine learning, if you don't know the shape, you're a really bad place, right? So here, the shape is now 3 by 3, and this is because very specific reasons. So the algorithm says that the output, here the O shape, right, is the input, or the weight here, the W is input. This can be the width or height. Usually they are both the same. If you are different, then you can have 2 equations. So I see Christopher is asking something. I will look at it. So, and then let me show you here. So this is the equation. So the output is the dimension that will come out of the kernel operations. The W is the input size that we have here. So this, you can imagine 32 by 32 bit image, right? 32 by 32 resolution image, right? The kernel in all of these examples is 3. So the 3-dimensional kernel, 3 by 3, right? The padding is 2 times padding. The padding in this example here, you see the padding is 1. There is 1 padding around the image, the blue lines. And the stride is the jump, like how much you jump, like what is the value of the jump. So if you see here, the stride is 2. It's jumping always by two elements. So the output is if you put all of the numbers here, you will get the output of the next, like this matrix that will come out. And is Christopher is asking, is the filter size something that we define? Yes, the this is, we define all of these parameters. We define, basically we know the input, we can rescale the input, right? The images, make them larger, smaller. The kernel size we can change, the padding we can change, the stride we can change. We can change almost everything here, right? So, but this is what we decide on, right? So this part is cool then. The next part, basically, so maybe I will add, is that we're gonna make the first model. I'm not sure where my code, I lost it somewhere. So the model will look like this. So let me see, I can copy the image, right? So this is going to be our first convolutional model. And if you look carefully here, you should look carefully about the details here. So see that here's the kernel size 3, stride 2, padding 1, out channels 2. Then again, the kernel size 3, stride 2, padding 1, out channels 4. Remember the in channels, out channels are those things that we have here. So here are 3 in channels, 2 out channels. It can be also 2 in channels, 3 out channels, whatever. So it's something that just how many of these kernels there are, right? So here there are the channels, then the relu function that you already know, right? So you apply the relu function on that output image or the what's called feature map, right? So these things in between the convolutional channels are called the feature maps. At the end, you have batch, 10, so we have 10 classes that we want to predict. That means that at the end here, we will need to have some kind of output that we can reshape, change the shape to the b times 10. So what I mean by that is probably you will have something like this, batch, so there is a channels, 10 channels, 1, 1. So in other words, it means like batch channels with height, basically that is what it means. And then you can reshape it quite easily to batch. So sigma, yeah, relu is better, but also the relu is simpler, and like people have tried so long time to change all of these activation functions, and basically at the end they decide, like the research shows that there is actually nothing really better than relu or leaky relu. They just like lose time on inventing all sorts of functions. It basically doesn't make sense that much, because when you have a lot of dimensions and you have nonlinearities, it really doesn't matter that much what kind of loss function, what kind of nonlinearity function you have. So anyways, this is what you have there. And the other thing what will be here is let me go to Google. Oh man, it's quite so slow. So we will use the fashion MNIST dataset. So this dataset contains 10 classes of grayscale, all sorts of images regarding the fashion items. So our AI model should predict which fashion item is it. Basically, if you can implement this model, you can implement all sorts of cool models. You know, you can classify, let's say, from the images, the faces, or let's say some other items. I know that, like even in the TensorFlow, some kind of presentations, they show that in China there were some farmers that use TensorFlow to classify using these kinds of models, like cucumbers, you know, like which size they are, you know. So anyway, so we will do this. So we will use this dataset to do this operation, fashion MNIST, right? So we're close to the end of the session, but let me show a couple of things so I can set up at least some homework for you. And so the dataset loader it's already here. So I added dataset loader for you. I also added here, I think somewhere it was maxlen. I want to see if it's actually in use right now. Yeah, so for the training purposes, for the actually debugging, reduce number of samples. So if you have the full number of samples, it will be basically very slow for you to debug the code, right? It's better to go over this. So here, if you look and add the breakpoints later, you will see that we are doing the same thing as before. We're generating the 10 class vector and then setting that this class is 100% true, right? And in X vector, we have actually the image. So this is in the shape of 1 in grayscale of width and height, right? And now there are a couple of new things. So one is the torch dataset. So there is a class that gives out every single item in dataset by index. And then there is another class called data loader. And this is mixing together all of these samples in batches and batch size there's also, do we want to shuffle them, right? And then there is a model. So model will be convolutional model that we're going to make. And then below there is a like training loop. And I also added that we have a training dataset and test dataset, 2 datasets. So because we want to train the model on one dataset and test it on another dataset to make sure that it learned not every sample, but the logic behind the samples, right? So we need also to implement loss function here. So the loss function, I know we are end of the session. That's why maybe, let's say this is going to be the last question probably. So what kind of loss function we need to use for this task? What kind of loss function we need for this task? So you should be a little bit more confident, you know. A lot of you just answer always with a question mark at the end. So that doesn't matter. Like actually, if you think about it, when you answer the questions, if you don't know really the answer and you answer confidently, you have like a chance of being a smart guy, you know. Like, so you have one answer. What about others? So I promise we'll end soon, very soon, and then I will set up the homework. So what loss function do we need to use for this task? So what kind of task is it, right? So this is a classification task. We need to classify which class belongs these items. So the like bags and shirts and trousers. So what kind of loss function do we need here? If you don't know the answer, please type in minus. I need to do other stuff as well today. One plus for crescent and cross entropy. So nice that we already have 2 people alive still. Please wake up. I want to go home and do some other stuff that I need to finish today. So two answers. Give me minuses if you don't know. So cross entropy, David's also cross entropy from Christopher's, cross entropy from Kirill. That is correct, right? We need a cross entropy, and you already did this today because we did the classification, right? So you know how to do this already, so that is good news. So let me show you the last stuff that we need to do there here, and I will update also the template for you so that you can do this as a homework later. So we need to create the convolutions. So this can be the self convolution 1. I will make the first one for you, so let me help you to do this. So if you look at the definition here, So if you look at the definition here, we can see that there is a first block up front after the input. It says kernel 3 stride 2 padding 1 out channels 2. So I will help you out with this one, and then you will do the rest of them, and then you will try to finish your homework, and I will also give you some examples here. So torch and n convolution 2-dimensional, that is our stuff that we need to use. So in channels are 1 because we have grayscale image, and the input is 28 by 28 if I'm not mistaken. Maybe I am, you need to double check it. So 28 by 28, and then the out channels, as I had written in the the task, is 2 channels. So I think it's 2 channels, right? Oh no, yeah, 2 channels. Then the stride is 2. Then the kernel, actually usually the people write first the kernel 3 I think it was, and the padding as 1. So padding as 1. So then let me show you what you need to do. So is in the forward pass you would get out the first out. So this is going to be the feature map 1. So this is the one that's coming out from the first convolution. Then you pass this one, and now you need to calculate the output size. It will not be any more 1 by 28, right? So it will be different, of course, by the formula that I gave you. And you need to get to the last layer of the fully convolutional layer, fully connected layer of the just simple linear layer at the end. And then you need to add the softmax at the end. So basically what you need to do here is the add next layers, then to do add linear layer, linear, or other words fully connected, FC layer. Then to do add softmax. By the way, softmax you can add also in the bottom part because softmax don't have learnable parameters, and relu also don't have learnable parameters. So like that. And then you need to complete the loss function, and that's basically it. So I will leave you with this. I will also update the template so you have these few lines to start playing around with this. And if something is not clear, then write me in WhatsApp or whatever. And this will be your next task. You will need to complete that model that I showed you using these equations, because basically at the end you will need to probably reshape it a little bit. So it's better to track the sizes probably. Maybe it's not important. You will find out when you will try to implement it. So I hope that today was fun. It was long and hard, I think, but we're getting there. I think. So yeah, please do the homework as best as you can. If you cannot do it, then please do it those parts that you can do. For example, the loss function probably you can do. Hopefully you could do also convolutions, because I just gave you example and explained it. So please try your best for the next time, and next time we will dive in deeper in the convolutions. It will get even more complicated because the machine learning is really cool stuff, and you can do great things, but you need to work your own. Okay, so that's it for today. Thank you for joining, and meet you next week, right? Bye bye.